Hello, I'm Pam Hoffman, Everyday Spacer.
I'm Jeff Miller, 2049 Outfitters.
At Everyday Spacer, we show regular folks how to personally and directly participate in space exploration, science, and astronomy. We're here on Friday nights at 9 p.m. Pacific Time, 12 midnight Eastern Time, and 12 noon on Saturday in Hong Kong. We're broadcasting live from Thousand Oaks, California. We will have time change, though, locally in the near future. We're going to talk about that a little bit more, but just watch for that.
If you like this video, please subscribe and hit the like button. Thank you.
So tonight's episode, we are going to have a crunchy topic for you: sprites and other spooky atmospheric effects. We'll be back in 8.3 seconds. A couple of weeks ago, we got a very interesting question during the show. Eric Draven asked, any chance you could share any insights regarding red sprites? What a great topic for the episode right before Halloween. And I immediately thought of my friend's book, Floating to Space. It's the Airship to Orbit program by John M. Powell. It was published in 2008. Chapter 4 has an introduction to the Earth's atmospheric layers, and it's geared towards the topic of his book, of course, airships to orbit. Yeah, it's a nice place to start. Jeff, what did you find when you did your research?
Oh, well, here, let me go back here and
Sharing?
Yeah, go ahead and share.
Go ahead.
So there's a number of things that are happening in the upper atmosphere that we still don't know much about. We pretty much first, hey Cliff.
Hey Cliff, thanks for joining us. Yeah, crunchy.
Yeah. They didn't actually know about these officially, even though there'd been observations that were largely discounted by meteorologists until 1989.
Right, yes, when the first reports were.
And we didn't actually have any color photographs of any of it until later.
Oh.
Because most film does not, these are so dim that most film, the color portions of it don't activate.
Oh. And I take it you mean emulsion type film.
Yeah.
Okay.
And even some of the digital cameras. Hey, yes. Hey, Don.
Hey, Don. Welcome. Thanks for being here with us.
Even some of the early digital cameras weren't very good at it, at taking color.
All right.
Because they are so faint that, and they're also so brief that it's not like you can take a long exposure.
And it's pretty hard to get some of them as high as they are. You have to kind of see them from far away.
And that's the other problem is not only are they faint, but you have to be able to see them above the clouds. And most thunderstorms usually span a good chunk of the sky.
Yep.
So the photos are fairly rare because most of them are taken from aircraft.
Oh, okay.
That just happened to catch it as they were shooting something else.
Oh, I see. Okay.
So I think recently they've started flying stuff up there specifically looking for them.
Oh, okay.
But
that would certainly be a scientific mission for, say, something like JP's Airship to Orbit.
Yeah, and
because they float, they kind of have time to look around.
So there's a bunch of different things that we'll be talking about, and but maybe good to get a good primer on JP, on the atmosphere itself.
Yeah,
the different layers.
So in his book, JP covers 10 different layers. Oh yeah, let's show that right now.
I did. Oh no, you
there that way. In this Earth, in Earth's gaseous cocoons, and he has a funny comment in there about, you want to be really scared. There's really nothing but these layers of gas between us and the black. I'd love to read this whole chapter to you, but I will pick out a few highlights for now. one of the things he said was to make sense of this region, scientists have broken it up into layers. There are two main ways to categorize the atmospheric layers: by either their electrical properties or by their temperature. And sometimes descriptions of the atmosphere use layers from both systems. This is a big cause of confusion. The entire region seems to be between like 7 miles to 1,000 miles. It's also, he describes it as between where planes fly and satellites orbit. So we're kind of talking about that area loosely because things change. If it's a hot day or if it's been a hot summer, these things might move around some. I actually thought they were divided by height, but sounds like there are other things going on.
Yeah.
And I have another quote for you here. To simplify the process, scientists have compiled tables of information taken from average data gathered over many years. This block of data is called the standard atmosphere. This represents a model of the sky. It allows scientists, researchers, and weather forecasters to all keep in sync. Every decade or so, the model is recompiled, excuse me. JP includes this simple yet clear drawing, and he lets us know that he's referencing the 1976 model. So it isn't very modern, but I think this covers a lot of ground. These layers are considered the troposphere, and that's where we live. We think we live on Earth, but no, we live in the sky, basically. The tropopause, the stratosphere, the stratopause, the mesosphere, the mesopause. So there's these areas in between, and they're somewhat thinner, I think, typically.
Yeah, and they're the transition between one layer and another.
Right. Okay. So then there's the thermosphere and thermopause, exobase, exosphere, and as JP explains, each is its own unique environment, like the rainforests or the desert. Each has its own wild set of phenomena. Some of the layers are well known, others are still a mystery. I'll delve into one of the layers that I think will help explain this wild set of phenomena a little bit. I'm going to read just the first paragraph of the part about the thermosphere. And again, we could do a whole episode just on this chapter. Up next is the thermosphere. This layer begins above the mesopause and extends to 373 miles. The thermosphere is so named because it is the hottest part of the atmosphere. Temperatures can reach 3,140 degrees Fahrenheit. The temperature can be deceptive. You could still freeze to death in the thermosphere. Each molecule of gas has a tremendous amount of energy. However, there are very few of them. Heating not only depends on the energy in the object, but also how many molecules you contact. The few really hot molecules you encounter would not pass along enough heat to warm you up. This is another indication that suborbital space is a weird place. There's a lot of fun things in his book. He does cover these things that happen there, like sprites, and Jeff's going to really go into a lot of these. Tendrils, beads, trolls, elves, gnomes, TGF, mesospheric ice clouds, and there are indications that there is life in our atmosphere. I really like this part of JP's book, though, the zoo of lightning. Most people are aware of just one type of lightning, that big forked flash that threatens golfers and gave life to Frankenstein's monster. Move a little ways into near space, and a whole zoo full of different type of lightning emergence. I think that kind of gives you a feel for his fairly humorous take on this whole subject for his book and a little bit of his personality. I'm going to put the link to JP's book in the chat for you. It should be clickable once I get it in there for you as the full link. So there you go. Back over to Jeff.
Okay. Well, as she mentioned, there are a bunch of different
You want the whole
things. Yeah,
okay.
let's show this.
All right, well, back to here.
Okay. Sprites, tendrils, which he mentioned, which are basically parts of the sprites. These blue jets, regular upward superbolts. I don't know why they call them that. This is the only place I've ever seen them called superbolts, but hey. But they also distinguish between negative cloud to ground lightning and positive cloud to ground lightning.
Oh, interesting. Okay, I thought it was just one kind, but
No, it's whether, and it all depends on whether there's a positive charge in the cloud or a negative charge in the cloud, and it'll attract the opposite in the ground below it until the point where they discharge.
Okay.
And the belief right now, and my belief also, is that the same thing is going from the cloud to the ionosphere. And because here's the ionosphere, and this is a charged layer that bounces radio waves off of it.
Yes.
And that's, we use this for bouncing radio so that we can do more than line of sight. And I think most of the phenomena that we're talking about is balancing charges between the thermosphere and the ionosphere.
Okay.
But they also call this cold lightning.
Oh, interesting.
Because it's cold like a neon tube. Which unlike regular lightning, which has moderate voltage but really high amperage. So there's a lot of
the other way around.
No, it's amperage burns.
Okay. All right. I thought it was high voltage.
No, voltage. You can take a really high volt, like the Van de Graaff generator. Very high voltages in there, but low amps. That's why you can survive.
It's actually a specific range of amperage that your heart operates at, basically. If you get that.
Right. Well, also, if you go above a certain point, you burn.
Yeah, right.
Because, so voltage is just a potential.
Okay.
And the higher the voltage, the bigger a gap it can go. So what I'm thinking is that these sprites are very high voltage, very low amp, because they're cold.
All right.
In these elves, this image is actually wrong.
Yeah.
Because they've recently discovered that the color of these circles are red.
Oh, interesting.
And the reason why it took so long is because they needed to get sensitive enough visual equipment to actually see it, because this takes place in the ionosphere. So they've generally detected these through electrical pulses, not not through light.
Okay, so they didn't really know what color for a while, it sounds like. Okay. Yeah.
So this is the overview of it. And there's a lot more information on the sprites because these were discovered first. In reports go back to 1886.
Oh, wow.
But they were first photographed 4th of July, 1989.
Oh.
University of Minnesota.
Interesting. They're typically associated with a thunderstorm, right?
Right. And the different phenomena take place at different times. Like sprites are within 1 to 2 milliseconds of an actual lightning strike.
Ah, okay.
The blue jets don't necessarily have to have a lightning strike involved.
Okay.
They just happen because of now they're all involved in thunderstorms.
Okay.
Because they're all based on the turbulence creating a charge.
Okay, and that makes sense because of we got the one set and then the other set that they might change voltages and potentials and stuff.
So you've got see a couple of interested images of sprites. And like I said, they're fairly rare because they're fairly faint and you have to be above the cloud to see them. So this, they have different kinds of sprites. Jellyfish sprite, which is what you're seeing right here.
It almost sounds like that elves and the sprite together.
Yeah. Apparently, there is there's a circle that forms around sprites that's different from elves.
Oh, okay.
And
all right.
They don't really explain how it's different. They just say that it's different. So it may or may not be different.
So still a lot of mysterious stuff going on here.
Like I said, they're rare enough that we still don't know a lot. Like even my, talking about them being a discharge between the clouds and the ionosphere is just speculation based on the fact that the ionosphere is charged and the
Mm.
clouds are charged. I mean, we don't know it. We haven't proved it,
Mm-hmm.
but that's very reasonable.
Yeah, it seems very logical to me
Mm-hmm.
to think about that in terms of
Yeah. And then there's
cool.
column sprites, and a carrot sprite is a column with long tendrils.
Okay.
Usually reddish orange in color,
Mm.
with bluish hanging tendrils below.
Alrighty.
Now, my guess is that that's because that's just the type of atmosphere that is fluorescing.
Okay.
Because
Yeah.
nitrogen tends to go reddish, and oxygen tends to go bluish.
Okay.
So I think that it's just the different layers, maybe different voltages. I don't know, but there's different atmospheric components fluorescing, because if you notice, the colors are also kind of based on where it is vertically.
Yeah.
You know, because the blue jets are blue, but they're also fairly low.
Got it.
So they do, and the Sprite halo, which is different than the elf.
Seems like another problem is that these are so short-lived.
Mm-hmm.
It'll be very difficult to, like, you can't see a bird. You know, when you see a bird, you can lift up your camera and take a picture of it. These, you have to kind of catch it in the act with the camera pointed at it.
Right. You kind of have to see a thunderstorm and be hammering away digital photos and hope you catch it.
Got it.
But, you know, because even so, it's 1 or 2 milliseconds after a lightning strike. So it's not like you can, you know, say, you know, hey, shoot it after a lightning strike. Now, if you have a fast enough, you know, automatic trigger, you can go off of the light flash of the lightning strike and shoot it. Okay. But that still doesn't give you the other phenomena, you know, that aren't. And so I'm going to go with what they call upper atmospheric lightning.
Okay.
Which is all of this is the image that I showed you. And they talk more about sprites here. They generally last less than a millisecond to more than 2 seconds.
Oh, that's actually quite a long time.
But different types of events.
Okay.
And they're not small either. Like this sprite here.
Yeah.
Is 100 to 200 meters long, you know, wide.
Wow.
So it's kind of like 2 football fields.
Oh, that's pretty big.
Yeah.
The pictures make them look small, though, but they might be far away, right?
But, you know, you're looking at this cloud that's probably at least a mile long. You know, and so and remember, this is also a drawing, not a.
Right.
And they're talking about, you know, the same types of effects that they're seeing in Jupiter.
Okay.
On its poles.
So more weird lightning.
Now, where did I see it? Let me find it, because they Sprite is
is it an acronym?
Well, no, they call it. Where did they get it? They called it a backronym.
Oh, right. You were telling me about that.
Yeah. Oh, here it is. They call it a backronym, which is essentially a reverse acronym, where they started calling them sprites just because they were they didn't want to call it lightning because they weren't sure that it was actually lightning related.
Okay.
It was just something, and it was ephemeral, and so that's a sprite, and that was just a catch-all name that they used for until they knew what it was. But then the name stuck, and so someone got it in their head to actually make it an acronym by coming up with words.
Okay.
So, stratospheric perturbations resulting from intense thunderstorm electrification.
Okay.
Like I said,
who names these things?
They reached far to get that name.
Okay. Cool.
And so So that's Sprites. Now they're the jets, the blue jets that I,
Mm-hmm.
and here's a blue jet. Now you notice it turns red when you get certain,
Okay.
and these blue jets, whereas Sprites tend to come down
Okay.
from above, the blue jets definitely go up from the cloud.
Hmm.
But they don't have to be in relation to a lightning strike.
Okay.
One of the things that they believe is that there are, positive and negative um, zones in the cloud in different layers.
Huh. Okay.
And so it accelerates electrons upward.
Hmm.
And if it accelerates them fast enough, they aren't stopped by the negative layer or the positive layer that attracts them.
Okay.
So they blow through it, kind of like an electron gun in a vacuum tube.
Okay.
So this is essentially an electron gun created by the cloud
Huh.
that basically shoots electrons up into the atmosphere. And that ionizes the air and causes it to fluoresce.
And that would have been something we see in the televisions that were
The
cathode ray tubes.
Yeah.
The old style televisions, they had a surface that was phosphorus, and the gun would, they call it raster. They go real fast, back and forth, up and down.
Yeah. So basically, you could think of the lightning, the thunderstorm, as a death ray.
Yay.
However,
Okay.
there's not a lot of reports of actual damage caused. They do think that that one weather balloon had its payload dropped because one of these jets kind of electrically tripped the release mechanism.
Oh, interesting.
And, some planes land with mysterious electrical failures, and they think that these may be the cause of it. But they're so faint that they probably didn't even see it.
And there seemed to be kind of rare, so we got a number of factors going on there that.
And we don't know how rare they are because it's hard to see them.
Yeah, that's true.
But
especially when you're in the thunderstorm.
Right.
Itself.
Yeah. You have to be above it.
Yeah.
It has to be dark enough.
Or kind of far away, like that picture looks like you're maybe
if you notice
some miles away.
If you notice the telescopes here, we're on a mountain, which makes us higher than that thunderstorm.
Okay. Yeah.
So, they do think that they have caused damage, but it's hard to prove. And since, unlike Sprites, which are caused by lightning strikes or, real associated with lightning strikes, this can happen without the lightning strikes.
Okay.
So they can just shoot up, quote, without warning, unquote. That has to be a fairly active thundercloud, to produce enough voltage to do this.
Okay.
And so they've got a couple of different types. Blue starters, which essentially they say are appear to be blue jets that never quite make it. So they're just, they just don't go very far. Then there's gigantic jets, which are humongous. Gigantic jets can reach higher altitudes than blue jets, terminating at 90 kilometers.
Oh, wow.
Basically blowing through the ionosphere sometimes. So, so these are fairly robust phenomena, but again, I don't think you wouldn't be electrocuted by it.
Okay.
You might get a tingle off of it as it goes by because, really high voltage, but very low amperage going through kind of at that altitude. It's a near vacuum. But if you're right above the cloud, it might be a little bit more vigorous.
Okay.
And September 14th, 2001, scientists at the Arecibo Observatory photographed a gigantic jet. And that's the one that we see up there.
That
was double the height of those previously observed, reaching 70 kilometers. So that it wasn't even the highest one. Um, so then there's elves, which are these expanding rings.
That one's definitely red.
Yeah.
Someone's trying to get a hold of you.
Yes. If there's another one, that's my sister, because she tends to blow up my phone.
At midnight? For her?
No, yeah, maybe.
Okay.
So here's chances are real darn good. That's my sister.
We'll check later.
Yeah. So these elves typically last just 1 millisecond.
Wow. I'm amazed they got that photograph then too.
But expanding glow around 400 kilometers in diameter.
Huh.
But again, very, very, very faint.
Wow. Interesting.
So, and they're so faint that the color was unknown for some time, but is now known to be red.
Okay. Also red.
Right.
And they're shown at the top of that sprite. So again, that's sort of that height.
Right. Yep.
Maybe that color too. Okay.
Yeah.
And we know there's different levels of, amounts of molecules at different places. So.
Right. Yeah. And again, they made something because they just named them elves to go in with sprites,
I see.
Other things.
Yeah. Who makes up this stuff? It's like the computer guys. They make up weird names too.
But yeah, I learned the word backronym from this article. I'd never heard that word before.
No.
Then there's trolls, because of course, why not call them something
Is that also a backronym?
Yep.
Yay.
They often occur after strong sprites and appear as red spots with faint tails, and are on the higher speed. Yeah, and on higher speed cameras appear as a rapid series of events, starting as a red glow that forms after a sprite tendril and later produces a red streak downward from itself.
Huh.
So these are kind of returns off of, yeah. So this happens after sprite. Then there's pixies, which first observed in the summer of 2000 on the high plains. A series of unusual white luminous events atop the thunderstorm were observed over a 20-minute period, lasting on average 16 milliseconds each. So these are fairly long.
Still, that's not very long in terms of
blink and you miss it.
Yes. Kind of normal human times.
Yeah. They were later dubbed pixies because, of course, you have to go with the naming convention here. Speaking of which, whenever I see a story with pixies, I always picture myself with a badminton racket.
Okay.
Just you see Tinkerbell and thunk.
Okay.
I get that sound in my head of the sound of a badminton racket hitting the birdie. Thunk.
What's next here, Jeff? I see something called ghosts.
Yep.
You ready for that?
Yeah. Well, the pixies are 100 meters across. So again, the size of a football field. Mm-hmm. And are not related to lightning. So this doesn't have to be a lightning strike. It just has to be a bunch of electrical stars built up.
Okay.
And then ghosts. Green emissions from excited oxygen in sprite tops.
Okay.
Yeah, so are a faint green glow that appears within the footprint of a red sprite, remaining after the red has dissipated and fading away in milliseconds. Possible examples of ghosts can be seen in historical images. But they were first noted as an exclusive phenomena by storm chasers Hank Shima and Paul Smith. No scientific journals or papers have been published on these, but their green glow has been speculated by observers to come from excited oxygen atmospheres, much like how auroras appear green.
Okay.
And then there's gnomes. Not your garden variety gnomes.
Nope.
The gnome is a type of lightning that is a small, brief spike of light that points upward from the thundercloud's anvil top, caused by a strong updraft which pushes the moist air above the anvil.
Okay.
It lasts only for a few microseconds. No, that's long considering everything else is in milliseconds.
Right.
So this is on the order of a real light. So this is actually, I think, lightning that's just following a path. It's like cloud to cloud lightning that's hitting moist air that gets pushed up above the cloud.
Okay.
It's about 200 meters wide.
Wow.
And is a maximum of 1 kilometer in height.
Okay.
Yeah, its color is unknown and has only been observed in black and white footage. So that's, and unfortunately, that's pretty much what we know about these. There are a number of articles on them. Sprites, elves, and glow discharge tubes. I think that's a fancy way of saying neon tubes. Because that's essentially what they're thinking is happening, is that it's very high voltage, very low amperage through a rarefied atmosphere. And that's a neon tube.
Okay.
But there are a number, and this article is referenced in there talking about atmospheric phenomena. It doesn't say much that is different from this wiki article, but there are some things in here that are, they bullet point things, observations about them. So you can get a little bit more detail on this one. And they don't talk about gnomes here. They talk about upward lightning, which is essentially what they were describing.
Sounds like a gnome, yeah.
Then they also mentioned tiger, which they broke their naming convention, but transient ionospheric glow emissions in red. Okay. Whereas since sprites and elves emerge within a few milliseconds of the nearest lightning strike, but a tiger takes 250 milliseconds to leap into view after a lightning strike.
Wow. Okay.
So, they're thinking that there's a different mechanism there.
Okay. It looks like it's to distinguish it between the others. Okay.
Yeah. And it's just basically the time.
Interesting.
And here is a different take on the same thing.
Magnify that. It's pretty small.
Yeah. There we go.
That's better. Thank you.
So, troposphere, where we live.
Right.
And the clouds and stuff. Ozone layer is right here at the top of the stratosphere.
Yep.
Mesosphere and ionosphere. And that's where the auroras are. And that's, I think, what's happening is that stuff is blasting from here all the way up to there.
Okay.
And you would need a heck of a lot of voltage to get there. And then here's a really neat site that I'll be putting a link to. This is spaceweather.com. This has basically, I don't know that this is all the photos of sprites and other phenomena.
Wow.
This has a lot of them. And next.
That's pretty cool.
Yeah. Okay.
Oh, these are amazing. Yeah, definitely add that to the chat. So
yeah, I will.
Oh, it's still going.
Yeah.
Wow.
Yeah.
So they're kind of rare. They're kind of hard to catch, but over a period of time,
right,
people do catch them. So
yeah,
good.
And this is You Scientist had an article on them, and this is the Columbia crew saw that, and this is where they discovered the tiger.
Okay.
So it happened far after a lightning strike. And so that's this is a wrong type of lightning. Well, I don't think that there's a wrong type of lightning, just one that you don't know about.
Yeah.
And this is, New Scientist does want, it's not a paywall. They just want you to sign up so that they can send you to advertisers.
Hey, Ron, welcome. Thanks for joining us. Amazing information. I had no idea. Yeah, and here's the thing. We don't know a lot about it. So there's
Yeah.
There's a lot of room. If this is something that appeals to you and you want to try and delve into it, I would say, go for it. And I think there's didn't we do a citizen science? Did we talk about a citizen science project on?
Yeah. Well, sprites were mentioned in a citizen science project.
Okay.
But
all right.
I don't think they were the focus of it. There's one last thing for upper atmospheric stuff. This is air showers, Cherenkov detectors.
Cherenkov,
yes, Cherenkov detectors. Now, these are not something that you'll see. It's caused by cosmic ray particles and gamma ray particles.
It sounds like the TGF.
Hitting the upper atmosphere. And the trouble is that unless something really, really bad happened, there's not enough photons produced by this to be visible.
Okay. How the heck do they figure them out? They just have other detectors?
Detectable, yeah.
Okay.
They're detectable.
Okay.
And maybe on the very dark night you can see them, in very dark skies.
Okay.
But it's caused by, a cosmic ray or gamma ray going through faster than the local speed of light. Because the speed of light in a vacuum is higher than speed of light in an atmosphere.
Okay.
So it's kind of like the sonic boom of the particle going through the air.
Okay.
So it goes through the air faster because the air doesn't really provide any resistance to it. So it doesn't slow it down.
Okay.
And so the particle goes through the air faster than a light beam would go through the air. And it causes the photons, it causes, they go into what causes them. But you can't really detect them without a detector. You can't really see them without a detector. So I just wanted to hit it just because it is something that happens up there. It's just good luck finding it.
Well, and here's the thing. We're constantly discovering things and creating new detecting tools like James Webb Space Telescope that went up kind of recently. It's got a whole new set of tools that help us to learn new things and find new things and so on. Did you have some more? Oh, you're going to add the...
No, that's about it. And I'll start adding the things. Yeah. Like I said, we don't know a lot about them,
right?
But what we do, and that pretty much covers it. There might be a few people who have more theories with more math in them, but that's about it.
Well, Eric, I don't see you in the comments here, but I hope that get you started on the right path for some investigations and that's what we're all about here, is to pique your interest, to go take it as far as you would like to go. And who knows, we may revisit it again sometime because things constantly keep changing. Everything keeps changing. It's a great time to be alive. All right, so if you have some more comments, definitely put them in the chat for us. I'm going to go ahead with some stellar events this week, though, and we're talking October 27th through November 3rd. On the 27th, that is tonight, the moon is at ascending node. Tomorrow will be October 28th, and the full hunter's moon also is a lunar eclipse. It's going to be a partial. Oh, and I want to read this from the Farmer's Almanac. It's not a real spectacular type of thing, but partial eclipse of the moon. This eclipse is visible from northeastern North America. The moon will rise during the eclipse, and observers will only see a penumbral eclipse. The moon will enter the penumbra at 2 p.m. Eastern Time and the umbra at 3:35 p.m. Eastern Time. The moon will leave the umbra at 4:55 p.m. Eastern and the penumbra at 6:28 p.m. So kind of in the daytime, I think, right? Yeah, they won't be real spectacular, but there is an eclipse on the 28th. Also, here we go. October 29th, Mercury and Mars are in conjunction, and Jupiter, Uranus, and the moon are in conjunction. On the 31st, it's All Hallows Eve, also known as Halloween. November 2nd, the moon rides high. And November 3rd, we're back to the Friday night show. We have a guest returning. Who is it? Stay tuned and we'll tell you more shortly. Find us Fridays at 9 p.m. Pacific time on the Everyday Spacer Facebook page and the Everyday Spacer YouTube channel. Also on the 3rd, the next project for Globe at Night begins. That's going from November 3rd to the 12th. If you're in the Southern Hemisphere, you want to look for either Grus or Pegasus, and they've offered a choice this year. If you're in the Northern Hemisphere, you want to look for Pegasus or Perseus. The idea is to go out, look at the sky, and report back to the site. Apparently, this is very important work from our friend Mike Simmons. Also, Jupiter is at opposition. This is a great time to photograph this amazing planet in our solar system.
Okay, some other events and activities. Oh, by the way, all of the links are up. That
cool. Thank
you. The only
Jeff.
links that I didn't put up are pictures from sites that I have links for in there. So you'll see the pictures in them.
Yeah.
So other events and activities. November 5th, daylight savings time ends, but unfortunately not forever. We fall back and set our clocks 1 hour earlier that morning at about 2 a.m.
I think that's what it is, 2 a.m.
Which means that when you're driving to or from work, the sun is back on the horizon again instead of being set.
Yeah, and not everywhere in the United States does that, but here we will be changing, which will change the time of our show.
Yeah.
Yeah, one more.
New Worlds Conference. And it's November 17th through 18th, 2023. Join astronauts, artists, and experts in policy, education, and human health services. And it's dubbed the best little space conference on the planet, probably by someone involved in the conference.
That's okay.
It's in Bullock, Texas State Museum. I really don't want to know what it's a museum for.
Okay.
Those of you from England and Australia will know more about what I'm saying. 1800. It's at 1800 Congress Avenue in Austin, Texas.
All right. So if you or someone you know has done something interesting involving space exploration, science, astronomy, like that, we'd love to share our live. In fact, we will be sharing our live next Friday. It's November the 3rd, and Dawn Jenkins will be back as our guest. She is going to talk about her experience taking a road trip to see the annular eclipse in Corpus Christi, Texas. I can't wait. We talked about it a little bit today. She showed me a webpage on her website, and wow, very, very cool stuff. Lots going on there. We're so glad you're here. That's we had Cliff comment and Dawn and also Ron. I think this is the first time we've seen you here, Ron. Welcome. We're so good.
First time recently, I think.
Oh, okay. Before. And I know Janie Becker went to a heavy metal concert tonight with one of her friends. So she said she was going to miss our show, which is just fine. But yeah, it's funny because she's what do you think, like 90 maybe? She's going to a heavy metal concert. I love that. All right, folks, have a great week. We can't wait to talk to you some more about some more good stuff, and come and see John. All right. Anything else from you?
Come on, see who?
Dawn Jenkins.
I thought you said John.
No, Dawn.
I was confused there for a moment.
Sorry.
Now that's rare for me to be confused.
No. Anything else from you? And we will watch for your comments as well after the show. So thanks so much, everybody. We really appreciate you being here. Have a great week. Good night.
Good night, folks.